Video about power functions and kind of what the graphs look like. This is actually kind of expanding on that just a touch. And I ended the video talking about if you know what the power function looks like, you kind of have a general idea of what the graph looks like. I really probably should have said, you know what the end behaviors look like, but that doesn't necessarily tells us what happens in the middle. Okay? So, as an example, if we have something like 5x cubed minus 3x squared plus 2x minus 1, okay? Because the highest exponent is 3, I know what happens on the edges of the graph. I don't know exactly what happens in the middle, but I do know x to the third, that graph looks like this, okay? So on the outside edges, the same thing happens to this graph, okay? So the end behavior, I know goes up on this end, and I know it goes down on this end because this part is greater than 0, and it's a cubic. Okay? Now, notationally, how we describe that is, notice on this right-hand side, it goes up as x gets bigger. So we might say as x approaches infinity, y approaches infinity as well, because it keeps getting higher and higher and higher. So as we go out this direction, notice the y-coordinates keep going up. Okay? Now on the other side, the y-coordinates are getting down as we go further out. Okay? So as we go further to the left, so as x goes to negative infinity, the y is also headed downhill, so it's headed to a negative infinity as well. So this might be our description for the end behavior. Now, this does not say what's going to happen to the graph in between. It might do this, okay? It might be a little bit more extreme and have a couple of lumps in there. I don't know until I do some more work with the graph. But this is just focusing on what's happening at the extreme ends. Okay? Now, if our function had a negative leading coefficient, like so, then that x to the 7th, if I think about the power function for that, since it has a negative 6x to the 7th, that means it's going to be going downhill like this on the outside edges. So I know my graph out here goes this way, and then out here keeps going down. Now again, who knows what's going to happen in the middle without more work, but the focus of this is just what's going on the ends. So if I look at the left-hand side, if we continue going further left, so the x-coordinate goes to a negative infinity, the further we go out this way, the higher the graph is going to get. So y approaches a positive infinity. And if we go toward the right, as we go out this way, then x is going to infinity, but the y is headed downhill. It's getting lower and lower, so the y is going to a negative infinity. So our description for the end behavior might look something like so. Now, if it's an even exponent, we kind of have the same things involved. Okay, so let me add a page in here. Oh, if I can get it to. So if we have an even exponent, so the last one is always odd, those, I know I use specific examples, okay, but it didn't matter whether it was a 3, 5, 7, or whatever. So if we have an even exponent for our, I should use the word degree, so the highest exponent is even, so maybe it's a 5x to the 12th plus, and that's the highest exponent, 6x minus 2, whatever. Okay. Since k is greater than 0, okay, if I just look at the leading term, that graph, remember, would look something like this, because it has the positive leading term, is an even exponent. So the graph for this function, or any polynomial, kind of that matter, that has an even exponent with a positive thing, has ends that go up. It's like the outside edges of the u. Again, what happens in the middle, we have no idea without more work. Okay? But here, as x approaches a negative infinity, because we're headed this direction, the y is approaching a positive infinity. And then over here, as we go this direction, so x is approaching a positive infinity, the y is also headed uphill, so it's still going to a positive infinity. And then similarly, we could have a negative leading coefficient. Whatever. As long as this thing is even and this thing is negative, it doesn't matter what else is going on. Okay? If that's the case, then remember negative ones with even exponents are the upside down u's. So I know on this side it's going that way, that side going this way. Again, in the middle, not a clue on God's green earth what's going on. But on this left-hand side, as x goes to a negative infinity, so we're headed out this direction, the graph keeps getting lower and lower. So as x heads to negative infinity, y is approaching negative infinity as well, because the further you go out, the further down this graph goes. Same thing on the other side. The further you go out this way, the further down that graph goes, because that's what the little arrow tells us, right? So in this case, as x approaches positive infinity, y is going to approach a negative infinity there as well. Okay? So that's what we're talking about with the end behaviors. It's just what's happening on the outside edges of the graph, not what's happening in the middle. Without more work, we don't know if it bounces around or if it smooths out like a U, or it might even be more W-shaped or something. Don't know without further investigation, but we do know what happens on the outsides.